Everyone, we're group 6. We will be giving the final presentation for our project in smart dustbins with IoT notification. My name is Suhas Yogesh, and my group mates are Lloyd John and Dion Gavin. With the increase in population and a massive increase in the usage of disposable items, we have seen an increase in the amount of waste that we produce. Handling of this waste is critical to maintaining hygiene, especially in big metropolitan cities with a large population density. Handling of this waste currently has is this current system of handling of the waste is regular manual checking, which is a tedious and uneconomical way of doing it. We have identified three existing problems for this system. Firstly, unnecessary deployment of trucks and manpower to regularly clear out the garbage, even if they're not used to their capacity. Secondly, overfilling of dustbins and hotspots that fill up quickly, leading to unhygienic conditions. And thirdly, due to these unhygienic conditions, people would not want to touch the dustbins, hence often leading to people improperly disposing of garbage around the dustbin area. In addition to this, a dustbin ecosystem that works with proximity sensors makes the product more inclusive to differently abled people. So our proposed system of a smart dustbin with IoT notifications is a prototype which intends to solve this problem. Using IoT technology, automatic control of the lid and notifying the authorities of full dustbins is implemented. The objectives of our projects can be jotted down into a few points. To automate the dustbin lid opening so that there's no physical contact required. To use IoT notifications to keep the municipalities of that area alerted on the dustbin's measure of the garbage inside. To design a hardware architecture using ultrasonic sensors, Arduinos, LoRa module, and a TFT display. To also design a software architecture using the Arduino compiler, the LoRa packages, and the C programming language. And to demonstrate the prototype with ultrasonic sensors and all the other hardware and software requirements. We tested this simulation on Tinkercad initially. Moving on to the functionality, just a few points. The ultrasonic sensors are used to detect when a person is nearby, so the dustbin can open. It is also used to measure the amount of waste inside a dustbin. The servo motors are used to open the lid of the dustbin. Wireless communication between the dustbin and a computer terminal is used with the help of a LoRa module, and the TFT display is used to show the capacity status of the dustbin. Here is a mind map of our project and how we hope to wish that the prototype is used. We have a central monitoring system which every municipality will have. And using the LoRa modules, it has a connection with the different dustbins around in that municipality. As you can see, each Arduino MCU each smart dustbin unit has an Arduino. It has a LoRa module, the servo motors, the TFT display, the ultrasonic sensors, and also the ultrasonic, which is used for level and distance monitoring. Now, each of these smart dustbin units are connected to the LoRa module, which gives information, which information can be seen in the central monitoring system. To talk more about the hardware and software architecture, we now have Dion.
Hi, I am Dion. Now that we have a broad idea of the product, I shall go into the details of the hardware architecture and the different modules that are used in the product. Since certain modules such as the TFT display and LoRa module are not available on Tinkercad, and we were not able to procure these items, we have made the prototype using other available modules. The added advantage of this is that the software controlling the modules has been developed for all of the modules, and hence the product can be adapted as per availability. So as you can see to the right of the screen, we have the smart dustbins design as done on Tinkercad. We essentially use 4 hardware modules in it, and I will explain how they are interfaced with the Arduino as well as how they communicate with one another. So first, coming to the block diagram, this gives you a broad idea of what components the smart dustbin consists of. It uses an Arduino, as said earlier, as the microcontroller, And specifically, we use an Arduino Uno for the Tinkercad demo and an Arduino Lenado for the live demo. We have 5 external components, 2 of which are ultrasonic sensors, a servo motor for mechanical control of the lid, a LoRa module for communications, and a TFT display for all of the display purposes. Coming to the hardware components, we use the HC SR04 ultrasonic sensor, which is a 4-pin module, as you can see labeled. This sensor uses a high frequency signal at about 40 kilohertz so that they cannot be heard. This sensor calculates the distance and the range we have set for the object sensing sensor is a meter. When someone comes within a meter to throw the trash, it triggers the servo motor by sending a PWM signal to control rotation. Another sensor of this is mounted inside the lid of the dustbin to calculate the level, and one of its functions is it does not allow it to be open when the dustbin is full and sends a message for the trash to be collected. Secondly, it gives you an indication of how much of the dustbin is filled up and how much is left. Coming to the servo motor which controls the lid, we use a lightweight high torque servo motor which provides us about 2.5 kgs per centimeter torque. Now this motor, its model is SG90 and it is triggered by a PWM signal based on the states of the ultrasonic sensors. The reason we use it is, as I said, it's lightweight and high torque, and it provides us a rotation angle of about 180 degrees, which controls the lid. The third component we have is the LoRa module, which is for communications between the dustbin and the PC terminal, which is in the control room. We use it because it is low power and provides us a large range. When the dustbin is full and needs to be cleared, the LoRa sends the message that it is full. Since we were not able to procure a LoRa module, we used the HC05 Bluetooth module for communication purposes. It uses serial port protocol, hence the baud rates of the master and the slave must be set to be equal, else we will encounter garbage messages sent back and forth, which will be due to bit errors of a faulty baud rate, and we will receive faulty messages as a result of this. With regards to how we will display messages, the product intended to use was a TFT display as it is low cost and it uses active display, which means that you have a high contrast display on the screen. Now this TFT module was supposed to be mounted on the dustbin to provide status messages such as the dustbin being open, the dustbin being closed, the identification number of the dustbin, and also probably a phone number on the TFT display that would allow people to call the authorities in order to clear the trash if it isn't being cleared. Since we weren't able to procure a TFT display again, we used the OLED display, which is an I2C synchronous communication protocol device. Now this will be wired to the Arduino, of course, and for the purpose of demonstrations in this project, we used all the display to be done on the OLED display. Now additionally, we have LEDs on the dustbin which are used to indicate whether a dustbin is in use or not, so that it can be determined from a distance which dustbins are in use when you have a bigger system of smart dustbins in a particular area.
Thank you, Dion. I am Lloyd Lobo, and I will be discussing the software architecture of our project. The main process is the decision-making and control of the lid, and the sub-processes are the object detection and level sensing. Further, we need to display the status via the TFT and indicate it via the LoRa module. And after that, the trash is cleared. The flowchart is as follows. The dustbin displays in use until a person is detected. And if a person is detected and the dustbin is not full, the lid is open. Whereas if the person is detected and the dustbin is full, as well as if no person is detected, the lid is closed and displayed dustbin full. And then once the dustbin is full, if the trash is emptied, it goes back to displaying dustbin in use. Let's move on to some of the coding aspects used. The code we used uses the libraries Servo, LoRa, SPI, and Adafruit. Servo is used for the servo module, LoRa for the LoRa module. SPI is a synchronous library for communication, and Adafruit is a graphical interface. There are 7 functions that we have coded in our code, and 2 of them are for the ultrasonic sensors. The read ultrasonics lid returns 1 or 0 if a person is detected within a 1 meter radius, whereas the read ultrasonic level checks the distance and returns it from the top of the lid to the first level of trash detected. There are 2 TFT display functions. The first prints the case where the dustbin is still has not reached its capacity, and that will include a percentage as well as a green bar. Whereas in the case of print invalid TFT, a red bar will be displayed as well as the time since the dustbin has been full. There are 3 LoRa functions used. Transmit full is used to transmit a message to the central monitoring system when the dustbin is full. Transmit clear is used to transmit a message to the central monitoring system when the dustbin is emptied. And transmit hour transmits a signal to the central monitoring system for every hour that a dustbin has been full, to ensure that no dustbin is full for too long. Let's go over the project timeline that we have done. So over the course of 9 weeks, we went through this process. First, we started with the topic finalization. Then we moved on to discussing our modules and sensor requirements. And then we described our hardware architecture with these module and sensors, as well as the Arduino. Then we coded the Arduino in C language with the software architecture. Since we weren't able to completely build our project because of the coronavirus, we had a simulation ran on the Tinkercad software. And to display a simplified version of our project, for our demo, we procured some components and we have executed the program for the demo. Now, this is how each module could be tested in further. Ultrasonic modules on Tinkercad we can place a reflection point to ensure that it's working. And a servo motor based on the dustbin state will either open the dustbin or close the dustbin. Whereas the LoRa module sends state changes from the Arduino to the PC central monitoring system through LoRa, and the TFT display uses Arduino to initialize the states of the display. There could be some errors in projects due to faulty components. Now once this entire system is assembled, it could be hard to detect an error. A basic test to test if the components receive power would be to connect a component to the VCC of an Arduino in series with an LED. And if the LED lights up, it could imply that the component receives power. Other errors could include that if a person approaches the dustbin too quickly, there could be a delay in detection, leading the person to wait near the dustbin for it to open. Although this is the case, the 1 meter distance should account for this time. To conclude, our project is an IoT dustbin ecosystem, and we would like to see it incorporated in large corporations for effective time management as well as waste management. In the future, collection of this trash could be automated, as all the data is sent from the LoRa module on each dustbin to the central monitoring system. And this monitoring system can further send data to robots to automate collection. We hope that this can make a difference in society. Thank you.